This is example 2.6 where we're talking about pressure on a submerged inclined plate. So basically what we're trying to do is we're trying to find what the pressure is on this rectangular plate here. That's a triangular plate. And to do that, we're going to use the formula method for this case, and we'll do it with the integration method a little bit later. All right, so you want to have the pressure on the force on ABC and its location. So to do that, from the formula method, right, we have to first figure out what the depth at the centroid of the plate is. Our centroid is going to be somewhere here, right? We know it's 2/3 down the plate because it's a triangle. So we can start with that, right? So we can say maybe depth at centroid of plate. Right, that's our H bar. And that's going to be what, right? We said it's a triangle, so we know it's 1/3 down the plate. 1/3 times 4 meters. That's how long this entire rectangular plate is. But that would be how far it is along on this plate. It doesn't, we have to multiply it by sine of 60 because that's how far it's down. Sounds 60 degrees. That gives us 4 meters. Sine 60 is square root of 3. And so we're dividing by 3 and by 2, right? Because the square root, the sine 60 is square root of 3 over 2, so we get that. So we would get that is 2 meters times square root of 3 divided by 3. Of course, we could calculate that out, but I prefer to leave it as this because with the square root of 3, we already know we're not going to get any kind of good numbers. All right, so that means then we can find our resulting force, right? That would be Fr. That was equal to the specific weight of whatever we have here, right? This is ethyl ether, so EE, times our H bar that we just calculated times the area of our triangle there. All right, so we can say that's, of course, we're not given the specific weight, we're given this the density, so we can say that would be 715 kilograms per meter cubed times 9.81 meters per second squared. Our H was that next term here, 2 meters times square root of 3 over 3, and then the area is going to be a triangle, so 1/2 times the height is 4 meters, and the base is 3 meters. All right, that's a lot of stuff. Don't think that gives us anything good, so maybe we'll just punch that in the calculator. So that gives me 28,056.6 times square root of 3. Should be Newton. Does that come out? So we have kilograms per meter over second squared. That's a Newton. So now we just have to make sure that that square cubic meter cancels out, and we have a meter here, meter there, so it cancels out. So that is a good value, and that's just in case we need it. Let's calculate what this would be. It'd be 48,595.4 Newton, or 48.6 kilonewton. Right, so we want to make sure that we have those longer and more precise numbers, just in case we need them for other calculations. All right, so that's the amount of force that's on there, right? That's the value. So now we need to find its location, and we know to find the location, we first have to find the moment of inertia for the triangle. So moment of inertia. We know that. We can look that up, right? did that in statics. So Ix bar is equal to the base of the triangle times the height of the triangle cubed divided by 36. So in our case, that'd be 3 meters times 4 meters cubed divided by 36. That gives us 192 over 36 meters cubed. That's good. We want meters to the fourth. That's what we want. And so we can simplify this to see 16 over 3 meters to the fourth. That's our moment of inertia. So then we can plug that into our equation for the location of pressure, but maybe we'll do that on the next page. Have a little more space, so we can say that our YP, right, that was equal to Y bar plus IX bar over Y bar times A. So we already know what our Y bar is. That's what we calculated earlier, right? That's how far along the plate we are. So that'd be 5 meters, 4 meters divided by 3. 4 meters divided by 3 plus, we just calculated what Ix bar is. That's 16 over 3 meters to the fourth. And then we have to divide that again by 4 meters over 3, so that's nice. That we can cancel out. That's always helpful. And then the area is 1/2 times 3 meters times 4 meters. Longer. And then what can we get from that? Well, the 4/3 meters. Let's not forget those at the beginning. I tend to do that. And then the 3's cancel out. We have a 16 on top. We have a 2, so we have a 32 on top, and 16, so that would be a 2. So we'd have that 16 meters over 24. Expand that first one out, then we have 32 meters over 24 plus 16 meters over 24. And that's, of course, 48 over 24, which means 2 meters. Right, so we know that the pressure location is about halfway down this plate, right? Because that has 2 meters in that direction. So that's what we would find. All right, so using the formula method, we found what the overall amount is of the force, the 48.6 kilonewton, and we found where its location is. We only looked for the Y location because, of course, we know this is symmetric, so it would have to be on the line of symmetry in the middle here.